Okay, so good morning, all of you. So today we will be seeing how an IR filter transfer function, say, given an HS, how will you convert it into H set? So as I told, there are two methods. First method is impulse invariance method. And you have another method called bilinear transformation. We'll be seeing impulse invariance method today. We'll be doing some example problems also from this. Okay. Now, so to see the impulse invariance method, suppose you have an HS. This is to be implemented 1 plus s square plus say 5s plus 6. Let this be a transfer function of an analog filter, and you want to implement a digital filter corresponding to this filter, having this almost same characteristics of this filter. So how will you proceed? So you first take HS. Before that, let me get some feedback. The audio and the presentations are clear, right? Please give me some feedback.
Yes, sir. Clear.
Yeah. So HS is 1 by s square plus 5s plus 6. Then I think this can be written as 1 by s plus 3 into s plus 2. 3 plus 2 is 5, so 5s. 3 into 2 is 6. Okay, so this can be written like this. And if you convert this to partial fraction, this can be written as a by s plus 3 plus a by s plus 3 plus b by s plus 2, and find a and b. So from this you can see that the difference between 3 and 2 is 1. So hence you divide this by 1, and you can write this as 1 by s plus 2 minus 1 by s plus 3. So when you subtract, 3 and 2 subtracts to get 1, and remaining you have 1 by s plus 2. So you can write like this. So a and b are basically 1 and minus 1 each. So if these are available like this, you know that the poles, or this can be written as say some C1 by S minus S1 plus C2 by S minus S2, where S1 and S2 are poles. S1 and S2 are poles here, and they are minus 2 and minus 3 respectively. When you equate S plus 2 and S plus 3 to 0, you get that the poles are minus 2 and minus 3. So you can write like this, and C1 and C2, C1 is 1 and C2 is minus 1. Given the polynomial like this, say h is equal to 1 by a0 plus a1s plus a2s square plus etc. Suppose it's of order n, we can write this as 1 by s minus s1 into s minus s2 into these are the poles. This may be real or imaginary depending on whether you have factors or not. So you can write like this, and this can also be written as, in partial fraction, if you convert it, it can be written as sigma, say I equal to 1 to n. If n poles are there, you can write it like this, Ci by s minus si. This is of the partial fraction form, where you represent all the poles and all the poles like this. So this is basically C1 by s minus s1 plus C2 by s minus s2 plus C3 by s minus s3 plus etc. You can find which are the poles by equating it as partial fraction and finding a, b, c, d, etc. Okay, so if this is the case, this is sigma I equal to 1 to n ci by si minus si can be the general form of the transfer function hs. Okay. Before going to generalization, let us go back to this example where hs is 1 by s plus 2 minus 1 by s plus 3. hs is 1 by s plus 2. So let this be here. This will come back to this. Okay, now 1 by s plus 2 minus 1 by s plus 3. Okay, so can you find ht corresponding to this? Considering that the Laplace transform that you have done is unilateral Laplace transform. Unilateral Laplace transform or unilateral set transform, what does that mean? It means that your summation, whether it is integral or it is summation, it is on the positive side. So this is from I equal to 0 to infinity. If this is tt equal to 0 to infinity rather than minus infinity to infinity and minus, you have evaluated integral and summation from 0 to infinity only. So that is the peculiarity of unilateral Laplace transform. So assuming these Laplace transform are unilateral, you can find what is ht. So what would be ht? If you have 1 by s plus 2, if your signal is e raised to minus 2t, e raised to minus, suppose ht is e raised to minus 2t. Can it have a Laplace transform like this, 1 by s plus 2? ht equal to e raised to minus 2t. Suppose you have ht equal to e raised to minus 2t ut. Can you tell what is the Laplace transform of e raised to minus 2t ut? One of you, can you tell?
One by s plus 2.
1 by s plus 2. 1 by s plus 2. Correct. So this is 1 by s plus 2. Suppose you take unilateral Laplace transform of e raised to minus 2t. Unilateral Laplace transform. Let us write like this. There is no notation like this, but I just wrote it. Unilateral Laplace transform. So if you find unilateral Laplace transform of e raised to minus 2t, what will be that? You are basically finding from 0 to infinity e raised to minus 2t to e raised to minus st dt. So this is same as finding the Laplace transform of e raised to minus 2t ut, because when you have a ut, your integral normally changes from 0 to infinity. So e raised to minus 2t ut is Laplace transform, and the unilateral transform of e raised to minus 2t ut, e raised to minus 2t is same as 1 by s plus 2. Can you understand what I'm telling? So it is, if you are taking unilateral Laplace transform, means it is as if that you are assuming that you have a ut here, even though it is not there, because unilateral Laplace transform means you are taking integral from 0 to infinity. So now you have ht equal to e raised to minus 2t has a Fourier transform hs equal to 1 by s plus 2. So that means this has its inverse Laplace transform or inverse unilateral Laplace transform as e raised to minus 2t minus e raised to minus 3t. So this is ht. So once you get ht, you can find hz, right? How will you find hz? You need to sample it. Suppose you do sampling at t equal to nt. You have a signal. Okay, this is analog signal represented as ht here, suppose. If you take the samples at regular intervals at t, 2t, 3t, etc., basically you are sampling, or you can replace t with n capital T or capital T or Ts is the sampling interval. Capital Ts is sampling interval. So T you can replace with n capital Ts or T. Okay, let us write it as NT, but T is the sampling interval. So this you can write as e raised to minus 2 nt minus e raised to minus 3 nt. So suppose that this is h nt, or the sampled version, or it has become now discrete. Okay, this is hn itself. Since this is sampled, it is discrete. Okay, so how will you find h set? What will be the h set corresponding to this? Can one of you tell? Again, unilateral set transform. One of you can tell. So you can assume that you have a un here. So can you tell what will be the set transform corresponding to this?
One by s plus 2 plus 1 by s plus 3.
1 by
S plus 2
s plus 2
plus 1 by s plus 3.
plus 1
Sorry,
by
minus.
minus 1 minus 1 by s plus 3. This is Laplace transform. We are talking about unilateral set transform.
Oh, sorry, Z transform.
Yeah. This is of the form a raised to n un. You agree? These terms are of the form a raised to n un, where a is e raised to minus 2. T is a constant sampling rate. It may be say 0.3 microsecond or whatever it is. It is a constant. So it can be combined with 2. So let us write it as e raised to minus a1. So 2 into t can be represented as, or you write it as k1, constant k1. You don't need, so a is basically e raised to k1, where k is minus 2t. K1 is minus 2t. So you can write as a raised e as, sorry, a as e raised to k1. So this is of the form a raised to n ut, and you know that it has a set transform 1 by 1 minus a set inverse. This also have a set transform 1 minus a set inverse. And what are these a? These a values are basically 1 by 1 minus e raised to k1 set inverse minus 1 by 1 minus e raised to k2. If minus 3t is written as k2, minus k2 into set inverse. Okay. So this is the representation now. So h set is 1 by 1 minus e raised to k1 set inverse minus 1 by 1 minus e raised to k2 set inverse. Now what has happened here basically? So this is the h set. So e raised to k1 is another constant, set inverse is another constant. This you can very well implement in a hardware. Okay. Okay. So now let us see. So in our case, you had 2t. So this k1 will be k1. You can replace with the, suppose t is 1 second. This will not happen for normal audio signal or any image processing signal. But if you have, suppose your sampling rate is our sampling time period could be 1 second. 2t can be replaced as 2, and 3t can be replaced as 3. And this can be written as k1 and k2 become 2 and 3 respectively. So this will become 1 by 1 minus e raised to 2 set inverse minus 1 by 1 minus e raised to 3 set inverse. So previously you had some poles. Which are these poles? Minus 2 and minus 3. The poles for S equal to -2, now S equal to -3 are the poles. Now what are the poles? 1 minus E square Z inverse. This is equal to 0. Then you get Z as Z will be E square, right? This go to the side is become E square Z inverse. So Z become E square. And let us call it Z1 first pole, and second pole is Z2 equal to E cube. So what do you understand from this? Your poles and zeros, the mappings that have been done is basically your new or ZI is basically e raised to, what has happened here? Z1 was e raised to minus 2 or minus SI, where SI are the poles, S1 and S2. In general, minus SI into capital T, right? E raised to minus SIT, where T is the sampling time period. You can write it as TS. So if you do a mapping like this, the poles, now the poles are ZI equal to e raised to SITS, where TS is the sampling time period. SI were the previous poles in the S domain. Then new ZI will be e raised to minus SITS. So in this case, Z1 is e raised to minus S1 TS. You know that TS is 1 second, we assumed here. So S1 into this become e raised to 2. That is first pole is E square and second pole is E cube. So this is how we proceed with the transformation in our case. And this transformation from S to Z is called impulse invariance method. So let us see this in a more generalized fashion, where we assume that HS is sigma Ci S minus Si. Okay. So let us see that. HS is, suppose here HS is sigma I equal to 1 to n Ci by S minus Si. Okay. If this was your poles, or this was your transfer function HS, well, this is basically C1 by S minus S1 plus C2 by S minus S2 plus etc. Cn by S minus Sn. For Ci is C1, C2, etc. are constants. Okay. So how will you proceed? You find Ht corresponding to this. For that, you take inverse Laplace transform, assuming the transformation to Laplace is unilateral. So this become e raised to S1, e raised to S1t into ut and multiply by C1. So plus C2 e raised to S2t like this. So this is basically a sigma Ci e raised to SIT. So, and if you sample it at say with a sampling rate of capital T, your T will be n capital T. So this you can write as sigma I equal to 1 to n Ci e raised to SINT capital T. So now if this is your HT, you can very well find HZ is a transform. How will you find the transform? This is as if this is a raised to n un. Always the transform is unilateral, so you can put a un there. So a raised to un has inverse set transform set by set minus, sorry, set transform set by set minus a or 1 by 1 minus a set inverse for a greater than 0. So this you can write as 1 by 1 minus e raised to sit. This is a here because a raised to n means this you can write as e raised to sit raised to n, which is a raised to n. This can be considered as a. So this is basically ci into 1 minus e raised to sit 1 minus a z inverse, okay, multiplied by z inverse. This is the for each term you can do that, so it becomes summation again. So it is sigma ci by 1 minus e raised to sit z inverse. So this is your set transform, and if you see the poles here, 1 minus e raised to sit set inverse is 0, or 1 is e raised to sit set inverse, or z is basically e raised to sit. Just put it, I'll just put it as set I. So each of the set i's will be, each of the poles will be set I equal to e raised to sit, si capital T. So each of the poles are now e raised to si capital T. So if this transformation is done, did we write it the same way? E raised to, yeah. Negative is there, e raised to sit. Yeah, in that case you had a negative sign. Otherwise, if you do for the generalized way in where we have s minus si, you get this. Si is like this. And hence this transformation, set I were each of the poles notated by si. You do e raised to sit, where t is the sampling rate, so sampling time period. E raised to sit gives you each of the poles in the set domain, and just substitute in the new set transform, where you can get the h set directly. So this method is called impulse invariance method. And next method, that is bilinear transformation, we shall see in the next class. So hope you got the idea with this example. Okay, so now I'll stop presentation. I'll send you this recorded video, and we'll have a quiz also. Today we will have a quiz based on only this class. Okay, definitely we'll be having it. Yeah, so I'm stopping recording now.